Design Explorer. I guess without further ado, we'll just jump right in and start the presentation. I have a number of things that I'm excited to share with you today. So the first slide, and we'll go through each of these, so it's a lot on here, but I just wanted to enumerate or just list a number of enhancements and updates that have gone into Design Explorer. This is HyperMesh Design Explorer on this first slide. And as you can see, there's some, they're colored by release here. There were a number of, I guess, sort of smaller incremental usability and other types of enhancements and updates that went into the 2024.1 release that are also listed here. At the time, didn't have a session for 24.1. So I think between 24.1 and 25, I wanted to include everything today. So I just wanted to mention them all here. We'll go through them all one by one in just a bit to share some updates regarding Design Explorer and Inspire as well. So as you can see here, Design Explorer has pretty good coverage in Inspire now. Structures was the initial kind of set of features that were supported in Design Explorer, and that's been there for several releases now. But over the past release or two, there are cases now that we can capture for implicit modeling, motion, and fluids cases as well. So I wanted to kind of mention that, and I have an example of each that I'll show towards the end today. So just kind of jumping right in to the enhancements. First for HyperMesh. So generative design itself is not an enhancement. It's not new. It was introduced in Design Explorer 2024. But just as a reminder, and as I'm not sure everyone is so familiar with generative design yet, or the workflow itself, it allows users to generate many design variants from an initial design space, as depicted on the slide here. So it expands on the typical kind of single run topology optimization, where you can define a design space, run an optimization, and review a single design concept. This expands on that by providing tools through Design Explorer to allow you to vary aspects of the design space in order to generate many concepts quickly and easily with a lot of pedigree maintained. And these concepts variants may differ subtly or greatly from one another while still achieving the desired design objectives. So it gives you many more concepts or variants to explore. The workflow also has tools, including in the third column here, kind of illustrating artificial intelligence-based concept clustering to help you review, filter, group the concepts for further investigation and down selection. So that's kind of a quick word about the workflow itself. Additionally, here's just a look at some of the features. Again, these are all there since 2024, but just as a reminder and a refresher, the workflow is a Design Explorer based workflow. It's embedded in the Design Explorer ribbon, and it works similar to the existing workflows for designs of experiments and optimizations. It's all very GUI based, using the tools in the ribbon for defining your design variables and responses, and then the other images depict the various tools that I kind of alluded to for reviewing, filtering, and choosing designs of choice. So for 2024.1 and 2025, there have been a handful of enhancements to that workflow. First one is the ability to run full factorial specification on generative design. So behind the scenes, generative design is effectively you're running a design of experiments where each run in the DOE is itself a topology optimization. Within each of those runs, Design Explorer varies the characteristics of the topology optimization. So it changes parameters that you tell it to change, or that it can change, like draw direction, minimum dimension, materials, and so on. And then it uses those parameters to vary the design through this DOE to generate different concepts. So how does it choose which concepts to generate or which combinations of attributes to try. And it does that according to the DOE specification that you tell it. MELS is the default for all designs of experiments in Design Explorer, and generative design is no different. So MELS, along with Latin Hypercube that you can see there, these are space filling algorithms. So they'll generate runs similar to what's shown in the upper right hand side there. That's just kind of a very simplified sort of 2D example of how the runs, or the points in the runs, will get chosen within the design space. So MELS is a space filling algorithm, and it will tend to generate runs, in this case concepts, that are similar to where those blue points are placed. So it kind of fills in the design space. In contrast, full factorial will evaluate every possible combination of the input variables. So in a DOE, generally this accounts for capturing all the effects and interactions in a DOE, which isn't really a concern, I don't believe, for generative design. But by using full factorial, we can generate every permutation of design possibility. So it takes all the design variables, and it runs every combination of them at their sort of upper and lower bound values, every permutation. So we can generate all the different designs more completely, and really more at the edges, if you will. So it provides that capability if you choose to use full factorial, which wasn't available before. Just as a reminder, the lower right-hand image, we have always had we've added the ability, if you're doing, say, MELS, and you're doing this space filling algorithm, and you look at your concepts and you want to generate more designs or more concepts, that feature is available as shown in the lower right, and it'll just continue to fill in the space by varying the attributes further and giving you more design options. But it still won't, well, ultimately it may generate all of the permutations if you keep going, but it's kind of impractical, and you don't get to the edges in the same way. So full factorial will let you do that in one shot. The trade-off, of course, is that the number of runs increases exponentially as you add more design variable options. So it's just something to be aware of. Another enhancement to generative design, adding this discreteness index information to the summary table in generative design. So as we've seen and discussed with generative design, you potentially generate many variants of your design, and the workflow already contains a lot of tools to help review, compare, down select, and so on. One additional tool now is the discreteness index, which is provided by OptiStruct for each topology optimization, a definition of the algorithm that's used to generate this index, and then just some words about it. Basically, it's a measure of the discreteness of the design. So ideally, when you're doing topology optimization and the optimizer is determining where to keep or remove material, in the ideal case, you would have a very discrete design where for a given element, it's either on or off, 0 or 1. In practice, as noted here from the documentation, that's difficult to achieve. So we want to achieve a design where as many elements or portions of the material are totally on, or as close to 1 as possible. So there's an algorithm that's used here to return the number of elements that are greater than 90% on relative to the entire model. So that's what the measure, sort of in a nutshell, is, and we'll represent that there. And again, it's just another tool for allowing users to determine which designs are more discrete and more desirable in that way. Another enhancement, so coming back to the sort of one of the AI tools in generative design, is the concept filtering. So what that does is, and that's been there since 24.1, as shown on the left, is it will group the designs according to a concept family. Basically, it's clustering them according to the element density. So designs that tend to look or be more similar in design can be grouped together. And it's a handy tool for helping you filter through and sort through all the different concepts that are generated by grouping them in families this way. On the left-hand side, the lower left, if you were to group according to concept, and then you pick on a particular concept family just by clicking on the, you know, the graphical image of the concept family, you would get a list of as you can see in the lower left, a list of all the different runs that were grouped into that particular concept family. And if you wanted to interrogate any of those further, it was a little disjointed. You'd have to jump back into the summary table. You know, you can see here in this example, it says runs 5, 7, 14, 24, and so on. You go back to the summary table, you could choose any of those runs that you wanted to interrogate further. You could load the results or have a look or whatever, but you had to kind of go back and forth. So this was another user suggestion. We've incorporated basically the entire summary table is now incorporated into the preview, the concept family preview as well. So what you see at the bottom right is the same concept family has been selected. Instead of just statically showing the runs, we actually show for each of those runs, all the information that's available in the summary table is embedded right here. And it's fully functional. The right click, the context menu is there, so you can choose any of the runs. You can certainly see all the different attributes there in the table, but you can load the results. You can load the simulation or element density results and interrogate further. Okay, so those are the generative design enhancements. Some additional enhancements that are available now, this one in 2025, again, compared to 2024 on the slide. Previously, in Design Explorer, you did have the ability, it was a little bit of a hidden feature, so to speak. You could enter into the number of runs. If you entered a number 0, we would just run the nominal run. So you could do that as kind of a model check or a, check your setup before engaging in a full-on DOE or optimization. So that's always been there. That's still there, in fact. For 2025, we've added the ability to run a check run. And this is using the, for those familiar, HyperStudy basic approach is what's actually being used behind the scenes. So if you select on an exploration, DOE or optimization, as shown on the right-hand side of this slide, you can select a check run. And then a check run will not only allow you to run a nominal run, as entering number of runs 0 would do, but you can also run the bounds check. And for those, again, familiar with HyperStudy, it runs 3 runs, as depicted on the bottom right-hand side of the slide there. It runs a nominal run, and then it runs 2 additional runs with the design variable values all set to their lower bounds and then all set to their upper bounds, respectively. So another good verification or tool before you commit to running a big DOE or optimization. You can do this check to see the nominal run and then check at the various bounds. And this is, in fact, I think this request came. It's especially particularly useful in a case where you might have shape variables in the model, which happens often. And then if you do a bounds check, it'll perturb the shapes to their minimum and maximum values, which can be a good way of checking for, say, any element quality issues that might come from exercising a shape variable. Often we'll see where if you perturb a variable to its extreme bounds in one direction or another, elements can potentially get distorted, or you could have contacts or overlaps or things that will either cause the solver to fail or would be undesirable in any sense in your model. So it's a good check for that in particular. Curve design variables. So again, looking at an older release versus the updated release, we've had this property design variable since at least 2024, as shown on the left. And effectively, it allows you, and I have a couple of videos on the next slide short videos that I'll play through that'll demonstrate both of these in a little more detail. But essentially, the property variable allows you to pick a property and then or an entity, and then allow a property assignment to be varied on that entity. So the example that's shown here is we've just picked it's a radios example on the left. Pick a component, and then you can vary the P shell assignment in this example. So by selecting the number of P shells on the right, within the exploration, the assignment of that property to that component can be varied throughout the exploration. So it was a good kind of catch-all. I think the video on the next Next slide will show it a little more clearly, but another example I think that's shown in the video is maybe you have like a 1D section and you want to allow a number of different section properties to be assigned to those 1D elements. So if you wanted to change from say a box section to a hat section to an eye section or what have you, you can allow that exploration to occur. Or even if you had a number of different, say, I-beam sections, but they had varying properties, you could vary them using this property design variable. So that's all still there, of course, in 24.1 and 25. But the enhancement is now you can select on various properties that might have curve assignments, and then you can vary the curve assignment. So a very typical or obvious example might be a material property. If you have multiple stress strain curves that you wanted to assign to a particular material, and you wanted to allow the exploration to vary based on those different material assignments, you can use this tool for that as well. So let's have a look actually at a couple quick videos here. Just the old one was shown in several releases ago. It's very short, so I'm going to show it again just to refresh everyone's memory where that property DV is and how it works, or how it's always worked historically. So in this example, as I described, we've got a number of different beam sections that have varying properties, and we want to allow those properties to vary or to be assigned to a particular component. So we'll select the component, and then we can see those different frame 1, 2, 3, 4 options that we had just shown. And there we create a design variable where now, just reviewing that design variable, you can see on that frame property, the 1, 2, 3 correspond to the IDs of those different sections, which can then be used within the exploration. So here's the enhancement. Again, under the same property design variable, we can select, in this case, materials, but it can be whatever type of attribute has a curve assigned to it. Pick one of the attributes, and then we can choose any number of curves, and there's a curve preview there that you can see to help you visualize which curves can be assigned, or which curves you are assigning. And then there we can see that it creates, again, a categorical variable, where in this case that curve assignment ID is what's varied throughout the exploration. Okay, next is trade-offs. So we've had, again, for some time now, these various predictive features: scalar prediction, field prediction, and curve predictions, as depicted on the slide here. Previously, those have been available only when you've run a design of experiments, or a DOE. So for every DOE that we run in Design Explorer, we have always generated not only a fit approach in HyperStudy, from which you can get the scalar response surface predictions, but we also provide the ability to do the field prediction. And then just recently, we've added the curve predictions as well. And as I say, those have always been available for designs of experiments only. For the latest release now, we've exposed those for an optimization as well. Because we always run GRSM optimizations, we're effectively generating similar data to a DOE anyway. So we've decided we can generate that fit based on the GRSM optimization. And then we've also allowed for field prediction and curve prediction to be available there. So even if you run an optimization, you have these predictive tools now available as well. Just a note, I think in 24.1 we added, maybe it was 24, in fact, the ability to extend DOEs. So if you've run a design of experiments, that's what's so in the just kind of describing what's happening here. On the top row, we've run a DOE. The look at the scatter plot just kind of shows the data that's been generated from the DOE, the number of runs, and where they exist in the design space. And then just for an example here, maybe we're interested in this prediction of the stress, and we can see that based on our R-squared value, we're not pleased with the quality of the fit based on the DOE that we've run. So before we allowed extending DOEs, which you could always do in HyperStudy, Design Explorer didn't support it. you would have to essentially, if you wanted to try again, you'd have to start from scratch. So instead of running, whatever this is, a 10, 11 run DOE, and you said, well, I want to try 20 runs to see if I get better fit, a better response surface fit, you'd have to start all over again in DE and run a 20 run DOE from scratch. Even though we've always been using MELs, we didn't provide the ability to extend that DOE. So that's been added. That's what's shown in the second row here is the extend DOE option. Once you have a DOE that you've run, so starting with the DOE from the first row, you click on extend DOE. You can see it generates what's displayed as kind of a child or an extension of the first DOE. You can specify an additional number of runs, and then you can see in the scatter plot there, we've added additional runs to our design space. And again, just for completeness, we go and we look at our prediction, and we can see that our R-squared value has also improved sufficiently from adding those runs. So that's been there for a release, the ability to do that, to extend DOEs to generate more runs. Initially, with that enhancement, we were not able to support field prediction or expert AI, but with the latest release, we are now able to do that as well. So just wanted to note that. So in other words, in the same way that the scalar prediction has been updated, the field prediction can be updated as well. It considers all of the runs, including the original and extended number of runs. And then you can get updated field prediction without having to rerun that entire DOE, and the same for expert AI. Some additional enhancements, just kind of smaller but not unimportant enhancements to usability, just always trying to continuously improve the workflow and the features. A lot of these have come from user and customer feedback, so we try to be responsive to that as well. Just a couple quick videos to show, again, these are small things, but also important. So switching design variable modes, again, in Design Explorer, all the design variables have a mode, they can be continuous or discrete. In the past, if you had created a design variable as a continuous variable and you wanted to change that to a discrete variable, you needed to basically just delete it and recreate it. So usually not a big deal, but sometimes it could be a pain. With the latest enhancement, just a real quick video. So here's just looking at the DVs in this model. This is a shape variable, but this applies to them all. We can see it's defined as a continuous variable, has a lower upper nominal value. We can just change that right here now to discrete. And once doing so, we get the discrete variable table that we can modify, however we like, to add the discrete values that we want. And now it's converted to a discrete variable. Similarly, back and forth. We can say, I don't want it to be discrete anymore. I want it to be continuous. And we can go back and forth like that. So just kind of a convenience and a nice enhancement that I think people were frustrated at having to recreate the design variables. In fact, some of this both of these, I believe, work as HyperMesh has now been enhanced in the way that was just shown for that one, and also for the goal creation that I'll show in a second. Both of those work in Inspire from the get-go. They worked as HyperMesh has now been enhanced. So it's also kind of nice that while supporting Design Explorer, we try to be consistent in the different applications, but we also kind of learn from one to the other as they kind of leapfrog each other a little bit. We saw that Inspire does some things in a nicer, more convenient way. So then we've gone back and we've added that to HyperMesh as well. Goal and response creation. So let me pause for a second. So creating a response, as always, you can create your responses, and then once you have your responses, you would come to the goals area in the ribbon, and you can take any response and make it an objective or a constraint. So that's still there, but we've added the kind of, as in Inspire, the one-step creation. So creating this mass response when the micro dialog appears, now you have this option. You can say, I want that to also be an objective. And now it's creating the response and the objective at the same time. Similarly, let's just do a displacement example. While creating the response, I can simultaneously create the constraint. So again, just making things a little bit easier, a little bit more convenience, and kind of trying to whittle away at some of the shortcomings or frustrations that users have found. Okay, so this is a 2025 enhancement. This is, I think, a little bigger one, and something that hopefully is going to be very useful and exciting. So it's a subsystem configuration design variable. So what's shown on the left-hand side is the subsystem configuration or subsystem panel or tab from the assembly ribbon. If you and users are using subsystems and configuring subsystems as kind of suggested here, then we can now leverage that in Design Explorer. And there's a short video will show you exactly what I mean. But in this example, we can see we've got this this frame model, and it has a couple different variations or subsystem configurations for the cross member. Two different designs. I've seen examples with different left-hand drive, right-hand drive vehicles, moon roof pano, or solid roof vehicles, and I'm sure there are many other examples. We have a customer who was looking at some configurations in an electric vehicle for the battery pack. And there were just different configurations of the different components of the batteries that he was kind of using this to swap in and out. He was kind of an early tester of this functionality. But let's look at the video, and I'll just show you quickly how it works. But first, showing the subsystem browser. And then in this case, we've already pre-set up. Actually, creating these subsystem configurations is kind of not really in scope for this talk or Design Explorer, but suffice it to say, in this case, the user has created two different configurations of this cross member and just toggling back and forth to show that they're there and what they look like. Now, how do we use that in Design Explorer? So here we're going to just kind of step through quickly some of the basic Design Explorer steps. We're going to create a DOE. In this case, we'll create a quick response. A couple of responses, I think a mass response, displacement. So this is just standard Design Explorer functionality, setting up the DOE. So we've got a mass and a displacement. Now we'll go and we'll select on the new configuration design variable tool there. And there's really not much to it. Those configurations exist in the model. There's only two of them. You can pick, there could be any number of them, and you would choose which ones you want to switch between within this exploration. And we'll run a quick DOE. In this case, there's only one design variable. You could add many more design variables to make this a more complete problem. But in this case, you can see a preview. So there you can see it goes pretty quickly, but you can see the quick snapshot of the different configurations that were used from run 1 and run 2. Apply variables to model, just showing the different variables from each model. In that case, the only variables that changed were the configuration, and then we'll just load the results for the two different runs and see that each subsystem configuration was used within the exploration. So a pretty simple example, but you could take that and extend that to use more examples or more design variables. Next, unnecessary runs removed. So this is the same model as the previous slide with the two configurations. So as we saw, just as a kind of an academic example, there's only two combinations are possible there because I only have one design variable. It's a categorical variable with two possible values. So there's only two runs possible in that DOE. Previously, that might have caused some confusion. When you send that to HyperStudy, if you request more runs than that, like in an optimization, for example, it defaults to 50 runs GRSM. But HyperStudy would quickly see that I only have two combinations that I can run. I've got configuration 1 and configuration 2, and I have nothing else I can vary. So in Design Explorer, you would see a run dialog or a status dialog with 50 runs. 2 of them would run. HyperStudy would say, okay, I'm done, and it would end. And that would and has caused some confusion. So we've just kind of added a quick enhancement here. It's the same setup as last time, so there's only 2 runs possible, but it's Mel's. I can request whatever number of runs I want. I'll request 5. Say I want to run this in using OptDestruct, and I'll run. So now we're going to see that it's saying I'm going to try to do 5 runs. HyperStudy is going to run the 2 that it can, and then now we're going to tell you we're going to delete those again, the video goes very quickly, I'm sorry, but we delete the unnecessary runs that we don't need, and then we show a little message in the status bar saying that we could only run 2 of them. That's all the combinations you told us, and we've removed the unnecessary ones. So just a little enhancement to try and avoid some confusion. Okay, last, I believe, HyperMesh DE enhancement for 2025 is easy to state, but I don't want to understate what I hope this will do for Design Explorer is we're now exposing the Design Explorer ribbon, Design Explorer ribbon, yes, in the Nastran solver interface, where it had not previously been. With OptiStruct, Design Explorer knows to evaluate responses primarily, not entirely, through like an H3D file. So if you've requested displacement or stress or some other response that's a result that's written to the H3D, Design Explorer knows to look there and to grab it and to evaluate that response. For Nastran, we're not going to get an H3D, and the responses may be written to various files depending on how your output file format is set up. So maybe OP2 or HD5 or punch file or whatever. So on where I've paused here on the micro dialog, you can make that selection while creating the response based on where your expected results are going to be written. So in this case, I created a displacement response. It'll look in the HD5 file to try and evaluate that response. So that's kind of one big thing to kind of be aware of or look out for. For the process to work, we need to know how to evaluate the responses, and we provide those options to let you select where to get the results and responses from. And then just a quick note, this same enhancement has been added to OptiStruct as well. So just in case you have cases where users are writing even OptiStruct output not to H3D, then we can kind of automatically try to evaluate those responses in those cases as well. Previously, you would have to define like a generic response or use some other way of getting the response output out of a non-H3D file. Okay, so that's kind of, well, that's it. But I think that was quite a few hopefully useful and interesting enhancements to HyperMesh Design Explorer. Now, as I said at the very beginning, I wanted to kind of take the opportunity, since I don't often do, and just recap and point out some updates on Inspire Design Explorer as well. So as I showed way back at the beginning slide, the first set of cases that we tried to capture with Design Explorer were in structures. So that just kind of means that the design variables and responses that were supported kind of fit into the structures domain. Well, since that time and over a few releases here, there have been enhancements to Design Explorer, again, primarily in the types of variables and responses that are supported, and a lot of those apply now to some of the other domains other than structures. So first, implicit modeling. It just kind of shows, I think, a very interesting example and case where implicit modeling has been used to define a lattice structure in this component, in this part. And really everything in Inspire Design Explorer wise, all the design variables stem from the variable manager, which is what's shown in the little image at the top left there. Because Inspire is, it's parametric, anything that can be defined and parameterized in the variable manager effectively becomes available to Design Explorer to use. So in this case, fairly simply, the implicit modeling was done. A variable was defined which corresponds to the density of that lattice structure, and a exploration was created. I think it's a DOE in this case, using Design Explorer. That variable was leveraged, some responses were defined, and very quickly varying that lattice density. And there's just some images at the right showing it at 20, 40, 60, and 80%. So you have all the Design Explorer features are exposed. Once you have kind of depicted here, Results Explorer is there. There's a run for each of the different densities. You can load the results. You can compare the results. You can look at things like linear effects and so on. So next example, this is an example thanks to Scott Ziemba provided this example to me. But this is just another simple example of a motion example where there's a mechanism shown at the right there, where there's a motor turning and then the mechanism turns. And the simple question here that was set up was I want to minimize the torque on that motor while I move the spring location around and try to, in addition, constrain the torque between values, in this case 450 and 500 Newton millimeters. So just looking here, you can see an example of, again, let's start at the bottom. The variable, again, it's just in the variable manager. Scott defined the location of this spring and allowed it to vary plus or minus 50 millimeters from the nominal value. So you can see the nominal value is 80 millimeters, measured from somewhere, but it can be as small as 30 and as much as 120 millimeters. So plus or minus 50. Well, not quite. It should be 130, I guess, but let's say plus or minus 50 from the nominal value. And then you use Design Explorer to set up your variables like that, and then your responses and your goals. In this case, there's a slide coming where Scott had listed out there's a tremendous number of different types of variables and responses that are all applicable to the motion cases. And I'll show those in a second just for reference. But in this case, he just created a torque response and said, I want to not only minimize it, but I want to maintain it between those values. And then here's just a look at the output. So in the top here, you can see the optimization that was set up as described in the previous slide. In this case, 50 runs were done. Again, that's the default for the GRSM optimization, but you can change that. But in just about 5 minutes or less, we're able to run an entire optimization and arrive at an optimal answer that does minimize the torque, and you can see from the constraints it's at 449, give or take, Newton millimeters, so conforms to our constraints as well. And then this next slide, again, as I mentioned, just shows the various types of design variables, so springs, dampers, contacts, motors, actuators, and so on, that are available and appropriate for motion problems. Looks like a couple more are coming right now for 2025 that can also be used, and then a number of responses that are again applicable. So the motor torque here was used in the previous example, but there's a whole bunch of others that could be used. So again, if you have users or customers who are Inspire motion users, something to be aware of and take a look at. And Scott did provide me with a lot more. There are several more slides that I didn't show, and some additional examples. So I would definitely refer you to Scott if you have, and to me, if you have interest in this and want more information. Final example I received from Shivaji Medita, who is the Inspire Fluids CFD solver developer, was able to provide me with this example. And frankly, the story is kind of the same. This is, as you can see, a fluids example. It's another simple setup. The pictures at the lower left kind of illustrate what's going on. There's water flowing through a pipe coming from the left here, and then being shot out of this spigot. In this case, there's a valve, which you can see in the light brown here, that can move up and down, so turning on and off, restricting or unrestricting the water flow. And he set up a simple design of experiments where the position of that valve is variable, and then I think there were two, well, they're shown here, sure. So the two variables, the valve position and then the velocity, the inlet velocity of the water is variable. And then one response that he was interested in measuring is the inlet pressure. And then set up a simple DOE. Here's a quick video kind of illustrating what was done there. The first part just kind of shows the model and then illustrates what the model looks like and then how this mechanism, the valve, moves up and down. There's a couple variables here. Again, everything starts with the variable manager. So this is just core Inspire, defining a couple variables that I mentioned, the valve position and the inlet velocity are there in Variable Manager. Now we come to Design Explorer, so all that pre-setup is done. In Design Explorer, like I said, we'll create a DOE. You have access to both of those variables. So there they are, very easy to define because they're already set up in Variable Manager. In this case, the user is just changing them from continuous to discrete. We'll skip through that very quickly and defining the different values that the variables can take. Then defining the one response. Here I'll pause again for a second. So sorry, let me get back to that spot. So similar to what we showed, say, for motion, which is also there for structures. So the responses, there's a number of responses now based on boundary conditions, temperature, pressure, velocity, and then based on that, there's some selections you can make, inlet, outlet, and so on. In this case, we're interested in the outlet, choosing a component of the average pressure at the inlet. I don't know if I said inlet or outlet, but it's the inlet. Then we're going to run a design of experiments that's being set up there. That's as far as the video goes. But again, it's very consistent with everything else. It would run I think it was 24 run DOE, where it's varying those variable values, getting a set of responses. But I guess the overall point is, again, just in summary, a lot of use cases now and domains can be captured with Design Explorer and Inspire. So not only structures where we started, but as you've seen, implicit modeling, motion, and fluids now as well. That's all I had to share. HyperMesh and Inspire-based enhancements for 25, and in fact, some of those are 24.1. So thank you very much. I appreciate everyone's time and attention.